Let's go into a bit more detail about what's happening when we prove something. We use the word proposition to mean a thing that it makes sense to try to prove. So calling something a proposition doesn't mean that it's true. It just means that the idea of trying to prove it isn't completely silly. So internally, Ask has a built-in data type called prop, which is the type of propositions. So if you think back to the first 2 weeks, we were writing things like prove P implies P. So here, P is a propositional variable, which is a variable standing for an unknown proposition. Internally, it's just an ordinary variable whose type is prop, just like you can have a variable of type n that stands for an unknown natural number. And the implies connective is actually a constructor of the prop type. So it's a thing that takes two propositions and builds a new proposition. So since P is a proposition, then P implies P is a proposition. So to show you what isn't a proposition, let me bring natural numbers into scope. Natural number is 0, or the successor of a natural number. So I could say, prove 0. And this doesn't make sense, right? 0 is not a thing that it makes sense to try to prove. And Ask will say, 0 cannot make a thing of type prop, which is Ask's way of saying, this is not a thing that you can attempt to prove. Similarly, I could try to prove n, which is the type of natural numbers, and I will get the same error. So we have a new way of making propositions, a new constructor for propositions. So I can write prove z equals z. So whereas z is not a proposition, z is a natural number, but z equals z is a proposition. So this is a thing that we can say. So a consequence of this is that all of the things that we had from the first 2 weeks are still available. We've added the ability to make new propositions by equals. So I can say, for example, prove z equals z and p implies p. This is a thing that I'm allowed to say. And if you think back to the first 2 weeks, if we had a formula where and was the top level connective, we know how to prove these. We say by and I, and that's still what you do. So when we do this, Ask generates 2 subgoals, just like it usually does when you say by and I. The first subgoal says prove z equals z, and the second goal says prove p implies p. And then the first goal, it automatically runs the two sides of this equation and proves that they're the same by tested. So then this is invisible. And then the other side, we just continue like normal. We can say by imp I. And then this Ask accepts this as a proof. Okay. Okay, I'm going to show you another trick that we can use to write some more proofs before we arrive at proof by induction in the next video. That is that we can use from on a data variable during a proof to tell Ask that we want to do a case split on the possible values of that variable. So for example, here's the booleans, data bool is true or false, and then I can write the not function from bool to bool by define not b from b, where define not true is false and define not false is true. So maybe I want to prove b equals not b. This makes sense because if I run not twice on any input, I should get back to where I started. We cannot do this by tested. The reason is that when Ask tries to run not b, it will hit from b and it will get stuck because it doesn't know what b is. The way that we prove this is we prove it by saying from b. And what happens is that Ask will generate 2 cases for the 2 possible values of a Boolean variable, one saying where b is true and the other where b is false. And these are invisible, but I can add them back in by saying where, and then the first branch looks like given b equals true, prove true equals not true. The second one says given b equals false, prove false equals not false. And in both of these cases, I can say tested. Okay, now to finish with, I'm going to show you a useful trick. Proofs about equality can sometimes be very confusing because you need to constantly reason about what happens when programs are running, because proofs about equations between programs always proceed by trying to run the programs. So sometimes it can happen that you think you're going to have to do a lot of work, but then Ask will accept a one-line proof using tested. And sometimes it can happen that you think that something should be very simple, but Ask won't accept it and you don't really understand why. When this happens, there's a way that you can interactively reduce both sides of the equation yourself using the test keyword. Secretly, this has actually been a feature all along. We just haven't shown it to you, that test can do symbolic execution. So I'm going to write plus, define m plus n to m where define m plus n from n where define 0 plus n is n, define successive. So in the last video, we saw that I can say prove z plus n equals n tested, and Ask accepts this. But if I say prove m plus z equals n tested, Ask does not accept this, and it asks us to prove something which is actually the same thing again, except that it's moved plus to its internal representation as the prefix operator. But this is really the same thing again. And so in the next video, we will actually prove this using induction. But for now, suppose you don't really understand what's happening. What you can do, so you can say on its own, test z plus n. And this will not work because it will say, I can't find n in scope, which is true. But what you can do, there's a trick you can do. You can just give a type signature to n. You don't have to give it a definition, just giving it a type signature is enough. And now n is in scope. And now, even though n hasn't been defined, Ask is able to tell you that z plus n is n. So it's doing a symbolic execution of z plus n, where n is some unknown variable. And then on the other hand, if I said test n plus z, here you can see that the program's getting stuck. So the reason that this happens is that when it tries to run plus, it hits the line from first input, and from means poke the input to see what it is, and then case split. And in this case, in the case where the first input is z, it knows that it's this, whereas in the case where the first input is just a variable n, then it gets stuck.